Hi everyone, this is Ms. Helms, and we're back for video number 2 of our special right triangles, our 45, 45, 90 triangles. So, in this example, this is the third example, we are given the hypotenuse, but the hypotenuse isn't like the other example. It doesn't have it as something radical 2. So, we have to think, well, how can we solve this? Well, starting off, we know that this is an isosceles right triangle. So, instead of having two variables, I'm just going to change this so that we have one, since we know the sides are congruent. Okay, so to solve for m, we can set up the Pythagorean theorem. So, we have m squared plus m squared equals 6 squared. So, 2m squared equals 36. Divide both sides by 2 to get m squared by itself. So m squared equals 18. And then to get m by itself, we take the square root of both sides. So you can take the square root of both sides and you can get a decimal approximation, or you can keep this in simplified radical form. So m is the square root of 18. Well, the factors of 18 are 9 and 2. So we know that 9 is a perfect square. And the square root of 9 is 3. What's left under the radical? That 2 there. So m is 3 radical 2, which means both of our side lengths are 3 radical 2. So this solves it. Ta-da! Done. However, there is another approach. So remember, in math, we always have multiple approaches. So if you want to try to use a shortcut, you can always do so. As we learned in our notes, we know that if our side lengths are m, then the hypotenuse should be m radical 2. That's the pattern that we notice. So really what we're saying is, well, 6 is equal to m radical 2. Okay, so our goal here is to solve for m. So to get m by itself, radical 2 is just a number, and this is multiplication. So this is m times radical 2. So to undo multiplication, or to use inverse operations, we're going to divide both sides by radical 2. And on the right-hand side, the radical 2's are going to cancel. And on the left-hand side, we're left with 6 over radical 2 equals m. However, this is a huge no-no in math, and this is something you're going to learn next year in Algebra 2. We do not leave radicals in the denominator. We want to rationalize the denominator. So, to do that, what we're going to do is we are going to multiply both the numerator and the denominator by the same number, because really, what is radical 2 over radical 2? That's just 1. So we're just multiplying by 1. We're making it so that it's proper, so that we don't have a radical in the denominator. So in this example, in the numerator, we've got 6 times radical 2. Well, that's just 6 radical 2 over radical 2 times radical 2. Well, radical 2 times radical 2 is just 2 equals m. And as you know, we always want to simplify our fractions. So taking a look here, we've got 6 over 2. Well, 6 divided by 2 reduces to 3 radical 2 equals m. So we did get to the exact same answer. 3 radical 2, 3 radical 2. One method, our first method, used the Pythagorean theorem. Our second method used our shortcut. You can use either approach. There are multiple ways to solving these. Whichever one makes more sense to you is the method you should use.